In this video, let's take a look at an application word problem dealing with the law of sines together. In this problem, there are going to be two angles of elevation that are going to be to a balloon that's in the air, and these are going to be from 2 points that are on the ground. One of these angles is going to be 27 degrees, while the other angle is 45 degrees. These 2 points on the ground are going to be 9 miles apart, and the balloon is going to be between the 2 points in the same vertical plane. Our job here is to calculate and approximate to the nearest tenth of a mile the height of this balloon above the ground. Let's start by visualizing what's going on by drawing a picture together. First, we need a balloon, and I'm going to use this blue circle to represent that. Then we need point number 1, which I'm going to use this square. And then there's point number 2, which I'm going to use this square to represent that. Now that we know what's what, let's go ahead and draw a picture. Alright, so this is going to be the ground. This is where I'm going to put point number 1. Here's point number 2. And the balloon's got to be between these 2 points up in the sky over here. Now remember, we were told earlier that these 2 points are going to be 9 miles apart, so let's go ahead and write that as our distance between these 2 points. Our angle of elevation from point 1 is going to be 27 degrees. So I'm going to go ahead and label that 27 degrees just like this. And we know our other angle of elevation is going to be 45 degrees. So hopefully this picture makes sense to you, and we can go ahead and use this to find out the height of this balloon above the ground. And the height of that balloon is going to be represented by this line here, which is going to be perpendicular to the ground. So this is going to be a 90-degree angle, and we're going to be solving for the height of this balloon, and I'm going to call that variable h. So I think that's all the information that they give us directly, but I think there's a little bit more we can actually figure out based on what they told us. We just have to think a little bit about what that might be. Now on this bottom left, notice how we have this 27 degrees, and on the bottom right, we have this 45 degrees. Now remember, the 3 angles of a triangle here are going to add up to 180 degrees, so we can actually use those 2 angles to figure out this missing angle up here, and that may help us a little bit more with solving this problem. Based on that, we should be able to say that if we take this 27 degrees on that bottom left, and then we go ahead and add on that 45 degrees, which is the angle on the bottom right. If we go ahead and add on one more missing angle here, that should equal 180 degrees. And if you add 27 and 45 and subtract it from 180, we're going to find out that that's going to be 108 degrees. So while they didn't tell us that directly, that's something we can figure out without doing too much extra work. The reason why it's useful to know that this is 108 degrees up here is because this angle measure is directly across from this side length over here, and so that kind of lets us know that the law of sines is going to be something that is going to be useful here. To figure out this value of h, or the height of the balloon above the ground, what we're going to have to do is take a look at one of the 2 right triangles. We're either going to take a look at this right triangle over here, and if that's the case, we're going to have to go ahead and see if we can find out the value of x, or the hypotenuse of this right triangle. Or we're going to go ahead and take a look at this right triangle, and we need to figure out the value of y, or the hypotenuse of this right triangle, to figure out the value of h. By using either of these right triangles, we can go ahead and use some trigonometry and calculate the value of x or y, and depending on which one you use those to then figure out the value of h afterwards. Now I'm just going to pick one of them, but feel free to try both if you just want to double check to make sure they both work, but feel free to just choose one of them. Now before we take a look at those right triangles, we're going to have to start with this non-right triangle and figure out the value of x or y. Remember, you don't have to find x and y, they're both going to help you get the right answer, you just have to choose one of them. To do this, we're going to go ahead and use the law of sines to help us out. Now just to refresh your memory a little bit, if we take the ratio of sine of angle A over the side length of side A, that's going to be the same ratio as sine of angle B over side length B, which is always going to be the same ratio as sine of angle C over side length C. Now for the way I labeled my triangle, angle A is going to be 27 degrees, angle B is going to be 108 degrees, angle C is going to be 45 degrees, and then we have this side length B down here, which is going to be this 9 miles. Now again, you can either solve for C or A here to go ahead and use the law of sines and then use the right triangles, which means that we're going to either solve for X or Y here, totally your choice. My preference though is going to be to solve for X, so let's go ahead and just focus on solving for this X over here, or C in the case of using the law of sines or this formula. Now to use the law of sines, we had to have one of these ratios given to us, or something that we could figure out. It turns out that in this particular problem, we know sine of b over b, or we know we can write that ratio based on what we have, because we have 108 degrees and we have 9. As for deciding whether to use a sine of a over a or sine of c over c, that depends on what we are looking for. If we are trying to find out this side length of y, that's going to be related to this angle a here, then we would go ahead and use this ratio. And if we were going to go ahead and solve for this value of x, then we need to use this angle of 45 degrees. So then we would go ahead and use this ratio over here. Now I wanted to solve for x, so let's go ahead and use this ratio to the right and use this sine of angle C over side C. So these are the two that we're going to use to set up a proportion. So here's the proportion that we're going to use. This 108 degrees is going to be angle B. This 9 miles is going to be side length B. This C degrees is going to be the 45 degrees. And this C or side length C down here is going to be this side length of x that we're going to solve for. Making some substitutions. We're going to have sine of 108 degrees over 9 on the left side of this proportion. And then on the right side, we're going to have sine of this 45 degrees over side length C, which we're going to solve for. And that's really just going to be our x here. So we can actually just write x instead. Now, if we just do a little bit of cross multiplication, the product of these two are going to be equal to the product of these two. Rewriting this from left to right, we can rewrite this equation as the product of x and sine of 108 degrees is equal to the product of 9 and sine of 45 degrees. Next, we can isolate x by dividing both sides by sine of 108 degrees, and we can write x is equal to 9 times sine of 45 degrees over sine of 108 degrees. Plugging this into a calculator, we're going to get that x is going to be approximately 6.691. I'm just keeping a few extra decimal places for now because this is not our final answer, but just to keep a few more to keep it accurate, and then our final answer, I'll round to the nearest tenths. So the 6.691 is just going to be this x over here. So I'm just going to go ahead and write that this value is going to be about 6.691, and that's going to be measured in miles. So using the law of sines, we just figured out the distance between the balloon and this first point on the ground. This is going to be about 6.691 miles from the distance between these two locations. Now that we have that information, we can just focus on this right triangle over here because we can go ahead and figure out the value of h, or the height of the balloon now. Now feel free to use the law of sines again if you would like to, but we can also just use our regular trig ratios here of SOHCAHTOA, or sine is equal to opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, just to help you out a little bit there. If we take a look at the angle measure we have 27 degrees. We also have the opposite side of h that we're looking for. And then for this right triangle, we actually have the hypotenuse now of 6.691. So hopefully that makes sense why we just spent all that time solving for it using the law of sines. All right, so using our right angle trigonometry, we can set up an equation and say sine of 27 degrees. That should be equal to the ratio of the opposite side over the hypotenuse, right? So the opposite is going to be h, the hypotenuse is 6.691. So I'm going to write over here that we have h, that's what we're solving for, the height of the balloon. And that's going to be on top of this 6.691. All right, let's go ahead and use this equation right here and solve it down below. All right, so just to get a little bit more space here, we have sine of 27 degrees is equal to the height of the balloon divided by 6.691. If we go ahead and multiply both sides by 6.691 and we isolate h, we're going to get that h is equal to 6.691 multiplied by sine of 27 degrees. Now if we go ahead and just plug this into a calculator, we're going to get that h is going to be approximately equal to 3.03. And so finally, if we're going to go ahead and round this to the nearest tenths place like we were supposed to from the beginning, h, or the height of the balloon, is going to be about 3.0 miles here. That's the nearest tenths place. Therefore, we can go ahead and conclude that the height of this balloon is about 3.0 miles above the ground. If we take a look back at the picture here, that's going to be this height that we just figured out, this value of h, and that seems pretty reasonable given the other measurements that we have here. So there you have a multi-step application word problem dealing with the law of sines, as well as using a little bit of right angle trigonometry. Again, at the end there, you didn't have to use the SOHCAHTOA acronym or those right angle trigonometry ratios. You could have used the law of sines again for the right triangle if you wanted to, so feel free to do that if you're more comfortable. That just about wraps up this video. If you found it helpful, please consider giving it a thumbs up and letting me know in the comment section down below. You can also go ahead and share this with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.